Hi, everyone. My name is Chandler Fife, and this is going to be my CIT 260 final presentation. So this is just going to be me showing some things I've learned over the course of the last half of this class. Hopefully, we're all able to implement some learning and things like that and able to come to a greater understanding of the concepts that are implemented here, and I'm able to demonstrate that for you guys. Things that we'll be going over will be static and non-static variables, arrays, array lists, and enums, how to implement catches and throws, character streams versus byte streams, and writing character data to an external file. So starting out, let's talk about static class variables and non-static class instances. So a static class variable is initialized when the class is loaded and is in all instances of the class that's created. So for an example here, we have our player class and we have the different elements that are going to be initialized with every instance of this player class here. So a non-static variable is initialized when an object or an instance of a class is created. So the class makes the player and applies the static variables to it. This is just that example that I was showing before. So let's talk about how to implement and use these different types of variables in a function. So for example, when calling a static variable, it's important to have an import of the previous class. And when you call that function of a static function, you state the class or an instance of that class, and you follow that by a period and then the function that you want to be using. So for example, in my code, I have my view inventory class, which is going to have an import from game control. And I'm going to be wanting to utilize a static function within the game control class. So I call the class game control. I call the function that's within it called get sorted item list. And in this particular instance, I want to pull that from the survival class in the current game. And there's the items that are contained with that are preset by the get item setter. And so that's essentially how I would call that static function. When calling a non-static variable, you have to create an instance of the class containing the non-static method. So like in the previous example there, if I want to create a player, I state the player class, assign it a variable, which will then assign the new player class to this variable. And that creates the non-static class. Let's talk about the arrays and array lists and enums that are generally used in our code. So an array is a list that contains objects of the same data type, and that array's length cannot be changed. However, the items within the list can be changed dynamically. An array list is a list which can contain objects of different data types, and the items can be added and removed as needed. The length is not fixed. An enum is a fixed list, and the items within it cannot be changed. So for an example here, I have a fixed set of different scene types of which that I've named after the different rooms that they occur in. And this list doesn't need to change, nor did I need to change any of the variables within it. So that's why I used this enum in this particular case. Below here, I have my array. I didn't have any additional items that I would need to be adding in this checkout item array. However, in case I wanted to implement something or change the variables within it, I used the array so that I could possibly do that. And that's implemented down here. For an array list, I didn't actually use an array list in my code. However, specifically concerning an array list, one application that you might want to be interested in would be like if you have an inventory that's retroactive and adding items in and out of that inventory. You would want to use an array list in that case because you'd be adding and removing objects proactively throughout the series of the game. So that's kind of just some examples of how would you want to use each of those arrays and how they're implemented in code. So array doesn't necessarily do all that much unless you can access the elements within the arrays. So this is just an example of how I was able to implement how I was able to access the elements within my array. So what you're going to want to first know is that there's an index associated with your array. In my case, I have my create item list, of which there are 2 items, 0 and 1, which can be referred to in this particular index. So the for loop in my code, which is down here, basically what that does is that allows me to reference items in my array by referring to their index number. So for example, here in my for loop, I have 2 different counters, which are assigned automatically to a number. So for this one, I have it assigned to 0, and this one I have it to I plus 1, so 0 plus 1. And basically what the purpose of this is that they're each going to go through the list in a loop. And so the length of time that they will be doing that is I less than item list dot minus 1. So for the length of the list, they will go through the entirety of the list and check this if statement. So basically what will happen is that I am going to be using this if statement to order my list in a fashion that is favorable to me. So for if j, or basically what will happen is that after it assigns these values to the variables, it's going to ask if item list at index number I, which is 0, it's going to look at the name of that element, and it's going to compare it to the item list at variable index number j, and get that one's name. And basically the compare to function here evaluates the string values of both those elements and decides which one is alphabetized correct, or which one is of lesser or greater value in alphabetically. If I is less than j, it will return a 1. If it is greater than j, so like if I starts with C and j starts with B, it'll return a -1. And then I compare that value to 0, and based on that evaluation, I order it using this switch statement here, which also assigns values based on this switch and these these references to the index, which are indicated here. So let's talk about how to throw, propagate, and catch custom runtime errors. So this is going to be using some try and catch statements. One of the first things that you're going to want to be doing is that when you retrieve input, which I have implemented here, which is going to be assigned to output location. This is actually a character stream that I implemented in my code. The try statement here converts it to a character, and basically it'll try to implement this view based on the input that you placed in there. And this code is very helpful because if any exception occurs, generally speaking, that will actually force your code to stop running and cause some, not damage, but it'll cause some complications. So when you're able to catch errors, which is implemented here, you are able to prevent those and actually display the error that is implemented here. So if they input a undesirable input, it will catch that error and return the message that is defined here. Let's talk about some byte and character streams. So a byte stream, it reads and writes binary data only and is used for Western-based languages. This was actually implemented in Java first, before they implemented character streams, which actually handles input and output of characters. So a character stream actually uses Unicode so that it can be used globally. And this makes your code more universal for other languages and things like that. And generally speaking, this is kind of the standard that you'll be wanting to use in any of your Java applications so that it can be more applicable to a wider scope of viewers. So in my code, I actually use a print writer character stream class. This is actually the same code that I had earlier. And basically what I have here is I have a print writer class. This will actually close out the file stream automatically based on the way that I've coded it here by implementing my try print writer out equals new print writer to the output location. So basically what this is doing is that's going to be implementing a new print writer and saving that to the output location of which that I assigned to earlier in my input here. So after that occurs, it goes through the code that I've implemented here to display a view of my inventory. And once it displays that view and calls the proper functions that are involved, it'll print that to the desired output location that I've assigned in my input here. Additionally, if there is any incorrect inputs, I have a catch exception here, which will implement or which will display an error message should a user input an incorrect input. So that's byte and character streams. So I hope you all learned a good deal about what I've been able to understand and capture during the midst of this course. I hope you have a great day and a fantastic spring break.